Imagine you have a friend who always makes great calls but can never tell you why. That is how AI works today. We use these models for health and factories, but they are black boxes. Most tools try to explain them by looking at every tiny dot of data. But people do not think in dots, we think in trends and shapes. We are going to talk about a way to make these machines talk our language by using high-level concepts. Suppose you have a machine making guesses. You want to know why. Figure 1 shows two paths. Path 1 takes a model that already exists and wraps it in a shell that understands big ideas like rising trends. Path 2 builds the model by feeding it those ideas from the start. Both use a clever trick: hide one idea, see if the guess changes. It is like taking a battery out of a radio to see if that is why the music stopped playing. Here is the math. We use something called shapely values. Think of it like a team of players. We want to know how much each player helped win the game. Instead of players, we use concepts like average level or wiggles. We look at every possible group of these concepts and see how the prediction changes when one is missing. It is a fair way to divvy up the credit, so you know which idea the AI actually cares about for its final answer. How do we get these concepts? We break the signal apart. Think of it like prisms for light. One tool, DWT, finds different levels of detail. We also made a custom tool that pulls out things humans understand easily, like the slope or how big the waves are. By breaking the signal into these pieces first, we can ask the AI which piece it likes best. It is just basic arithmetic to put it back together so the machine can still read it. Look at this graph. If you look at every single wiggle, you get a mess. But our method pulls out the big trend. It shows that the steady drop in pressure is exactly why the AI says the jet engine is failing. The old way gave us 1,000 tiny numbers that meant nothing. Our way gives us one big arrow that explains the whole thing. It is about seeing the overall shape of the data, not just the dots. We tried this on two real problems. One was tracking how people move using knee sensors. The AI used the knee angle and movement size to tell if someone was sitting or walking. The other was predicting when a jet engine will break. The AI mostly looked for a steady drop in pressure. These are things a human expert would check too. It shows the model is actually learning things that make sense in the physical world. So, what did we learn? We can peek inside the machine by using big picture ideas instead of tiny data points. It works for models we already have or ones we are just starting to build. It bridges the gap between cold math and human logic. The next step is to put this in front of real doctors and engineers to see if it helps them do their jobs better. It is about making AI a partner you can actually talk to and trust.